Hey everyone, welcome to the first video of Chapter 8 Enlargements. The first thing that we're going to do is take a look at the prior knowledge, which is more about area and volumes of certain 2D shapes and 3D shapes. This is going to be key knowledge for the rest of this chapter as well, so if you still have trouble or don't remember the areas of those forms you see right here, for example a triangle or a trapezium, a circle, and please watch this video carefully. We'll be going over them in this order as well. So we start with the area of a triangle. We've learned that the area of a triangle is equal to a half times the side times its matching height. And the matching height was part of the altitude between the vertex and the opposite side, right? So for example here I could say half times AB, and then the matching height was CF. Why? Well, that's going to be perpendicular on AB to point C. And sometimes you use different sides, then you use different matching heights. Just remember, the matching height is always perpendicular on that side and goes through the opposing vertex. Okay? And sometimes it can get a bit more difficult if you have an obtuse triangle, because then your height can be outside of your triangle. Because then I have to extend AB here till the point that I can get a line that goes through C and is perpendicular in this side on the extension of AB. Here as well, if I want a line that is perpendicular on BC and goes through E, then I must extend BC. Here it isn't needed, right? Because it has to be perpendicular on AC and through B. Hey, that's just inside of your triangle. So this is a copy-paste of a slide from chapter 2 when we talked about calculating areas of triangles. And then I asked you the same question. If I want to calculate the area of this triangle right here, what is the correct calculation? A half times sides AB times matching height CD, or a half times AD times matching height CD? Which one is correct? So the difference is, do I use AB, the length of AB, or do I use the length of AD? Yeah, the correct one is the last one, right? You use the extension to find my matching height, but when I use my formula, a half times sides, yeah, AD is not a side of a triangle, at least not of the triangle which I want to calculate. So I have to use the side AB and then just the height that I found right here. So 4 times a half, right? Don't forget the times a half, please. There are triangles, then we have parallelograms. There are some properties of parallelograms. We're not really going to calculate a whole lot on parallelograms, so it's more know how you can recognize them, which properties do they have, and if you want to calculate the area of a parallelogram was not that difficult, right? Because we could move this triangle to this triangle, then we would find just a normal rectangle, and then we said, okay, the area of this thing is just the edge times its matching height, which is again perpendicular on the side. And that's the same here. So you could do AE times BF, or times CG, or times DH, or times EI. Even MJ you could use, because they all have the same length. Okay, that's parallelogram. And I think this one occurs not that much in this chapter, but still very nice to know. Then we had a trapezium like this, where we had one pair of parallel edges, in this case AB and CD, and we call those edges A and B, and then we said, well, the area of this thing is a half times A plus B times H, or in words, a half times the sum of the parallel sides. A and B are parallel to each other, right? So we use those sides, add them up, and do it times the height. That was your trapezium. The last one that we hadn't discussed yet is the area of a circle, and that one was discussed previous year, and I don't think we have used it that much this year. Do you still know how I could calculate the area of a circle? We did that by doing pi times the radius squared, right? And you know what the radius is? The radius is the length from the center up to the rim of the circle. Not the diameter, right? If you have the diameter, divide it by 2 to find the radius. If you know the area of a circle, then maybe we can use it to calculate the volume of this 3D shape here. Do you still know the name of this 3D shape? It's called a cylinder. And to calculate the volume of a cylinder, you take the area of the base, that's a circle, so that's PR squared, and just do it times the height. So PR squared times height. That's why it's nice to know the area of a circle for this kind of calculations. And I think this was the last one. Yeah, that was the last one. So quite a few formulas, but all formulas that we had discussed either this year or previous year. Please review them again, practice some exercises because we will need them in the first few paragraphs in this chapter as well. Good luck.